Uh, I'm back from Antarctica, and I brought with me a wonderful cold, so I'm a little under the weather, but this seemed like it would be so much fun. I would cheer me up and get going. Fry, I wanted to apologize for any confusions over time zones and things like that.
It was my mistake, but the fucking calendar is just wrong.
Well, we're going to confuse everybody
on so many levels.
I want to warn everybody else that I'm looking at you, Andre. This weekend, most of U.S. changes clocks, so be prepared.
Well, I just
check the time again.
I didn't know my camera was off. Sorry.
Oh, okay.
I was talking like crazy, but
well, we heard you.
So, welcome, William.
In
William
full
W.
darkness.
Hello.
Now a little better.
Yeah.
Yeah, it's fine.
And I didn't really set a strong agenda for the meeting because I just a quick look at GitHub says that there hasn't been a lot of advancement on the software in the last couple of weeks, as I've been out of town, not cracking the whip on myself. But now that I'm back, I'm going to take care of moving things forward again. And but I've got to make some decisions about what to do first. Andre also sent me a PowerPoint on some new ideas, and what I'd like to do, Andre, is preserve that to the end of that meeting, and
sure.
And if we don't get there, we'll schedule a special thing next week, and
maybe we'll have some more prepared.
Yeah, and let you get started on it.
So you do like the idea?
I to tell the truth, I've been in bed and haven't really had a chance to look at the idea. And Fry had some comments on language and language processing and how we should approach that. And I don't know, I didn't get from your email whether that was an idea on how to do it, or you thought that language processing was a particularly better thing to be doing than the other ideas I put.
Let me just say a few things. First of all, I went to Vegas 2 weeks ago for 1 week, got COVID, and stayed another week. So I'm just recovering from that. I'm back in Boston now, but I'm still kind of tired. I have spent, Charles, quite a bit of time talking to Michael Miller since you've been gone. And about his ideas of patterned thought and all of that. So I could try to summarize what I think he's doing. That is something. And then I completed Ron Brockman's book. I read that whole book read a whole book for the first time in years, and I have some comments about that and how what the relationship between large knowledge bases and the whole psych project and those issues. So those are kind of like the big issues. This language thing was kind of a minor thing I just had at the end, and we can talk about that if you like. So those are the big topics I would put on the table. Is knowledge representation and psych, and what came out of that book, which Charles recommended to me, and what's come out of me talking with Michael Miller and his ideas and how they might be related.
I tell you a kind of interesting story about how I got to that book. That I went to an MIT. It was a program about artificial intelligence and quantum computers. That was a symposium, out of which, by the way, I should say, I concluded that quantum computers are interesting. And hello, John. Quantum computers are interesting and AI is interesting, but they really aren't very related.
I would think that's the case, yes.
And but sitting next to me was one of the managing editors, acquisition editors at MIT Press, and she recommended this book.
Ah, okay. Okay, well, it caught my eye because I knew Ron Brockman from way back when at BBN and clone knowledge representation systems. So shall I talk about it a bit?
Sure, go ahead.
Okay,
And by the way, the book is on the website if you're interested. That I just put it up there because it has some relationship to what we're working on. And we get absolutely nothing if you click the link and go to Amazon and buy it. I could sign up the form and get 15 cents for every copy. So
yeah, okay.
So I'd have 60 cents.
So anyway, Ron Brockman, I think he was a Harvard grad student or something back in 1980 or so, and I worked at BBN in Cambridge, which was the first AI commercial department. And recently left from that department was Danny Bobrow, who was a pretty important guy in AI back in the day. His brother Rusty Bobrow remained there and was an expert at English parsing, and that's how I really got. Well, that's how I got into the concept of knowledge representation. Okay, so that's forms kind of the full core of knowledge representation, and yes, they have a graph and there's labeled lines going between the elements of the graph and such, you know, nodes and directionality and all that kind of stuff. So Psych came along and spent 1,000 man years creating a curated knowledge base. 1,000 man years, a very large DARPA project. They spent 30 years on it. The code is locked up. It's hard to get at. And Brockman complains about, well, I don't really understand Psych because I can't get my fingers on it. So that's annoying. And I think, well, okay, is it really important to have a large knowledge base in a reasoning system? And I think the answer is probably yes. But then, okay, Psych is being so, I don't know, commercial or something and hiding away its things. So how do we get a large knowledge base without, you know, spending 1,000 man years to curate it like they did? And I think the answer is Charles has already got it. You got to create it yourself. You ride a robot that runs around the world and it collects it. And, you know, it can have some human intervention and all that. But I think that's basically the right idea. You know, Sally walks through your apartment and discovers gravity and all this stuff, right? So now it comes down to how do you build that 2-year-old, if we will, you know, and you could build it in almost any way. You know, humans can intervene. We don't have to be clever about building the 2-year-old, but then have it wander around and collect all this stuff, including collect stuff on the web and all that, and maybe make sense there. Now, one of the key ideas is how many different kinds of inference do we really need? They're sort of the initial capture of the knowledge and using some ideas of neural nets and perceptual stuff to grab, you know, images and sound maybe, and then do correlations between sound and images and all that. But then once you've got that stuff, then you've got to do some inferencing on it. So how many different kinds of inferencing are we really talking about? And Brockman thinks maybe a couple dozen. And I think maybe that's right. You know, maybe there's just a couple dozen, and that's manageable. That's like, okay, you could implement a couple dozen different types of inference, and then let that create the knowledge base. Now there's this trade-off between what do you store and what do you recreate or re-infer each time. And I think if I steal a page from Charles here, he's saying, you know, we probably do a fair amount of inferencing, not storage, but inferencing on a daily basis subconsciously. And we don't really know that, but it makes sense because storing that, you know, cats have 4 feet and dogs have 4 feet and lions have 4 feet, that's a losing game. But if you say, you know, most mammals have 4 feet, then we just saved a lot of memory, and that's a trivial inference. And if we can look it up quickly, then why not? So you think about, you know, stuff that's hard to compute and you store that, and maybe stuff that you compute a whole lot, you store it, but you rely on inferencing for trillions of facts, literally trillions of facts. And if you have this good, like, couple dozen inferencing techniques, I think you win on that. You don't have to do the storage. And you have to have those inferencing techniques anyway, because we want to build up stuff. Now, I've thought a lot about categories, and here's my canonical example is color. The concept of color does not exist in the real world. We have yellow and red and green, but generating the concept of color is an abstract idea. It's something humans did, right? Purple is a color, but purple isn't really on the spectrum, just for example, you know. So it really is this human invented abstract idea, but it's grounded in reality in a certain way that religion, for example, is not. So can we have this kind of inferencing that can be so smart as to infer categories like color? And I think, other than the word color, I think the answer is yes. I think we can infer categories. And then once we can infer categories, then we can infer categories of categories and move up the hierarchy. And inferring those categories is going to help us tremendously to save on storage. And then we can know that, well, all colors are in a set and colors have a certain characteristics, and we don't have to store, you know, the concept of wavelength of light inside of yellow and blue and green. You know, we just store it in color and you win. So, okay, so now we're down to making the 2-year-old, making the couple dozen inferences, and combining this together with the perceptual stuff that can wander around the world and start putting 2 and 2 together, basically start, making a machine that can invent the concept of color. And that's just one example. I mean, there's a zillion of them, of course. So this brings me, and Brockman is kind of pessimistic about AI. Oh, it's going to take decades and decades, and we're a long way from doing all this stuff. And maybe he's right, but we're not going to live for decades and decades. So let's see if we can speed it up and prove him wrong. So I want to say one other thing about Brockman, which is, I think it's a well-written book. I think it's worth reading. I don't think it's perfect. I also don't think it's advanced very much in the last, I'm going to say 45 years since Clone. Not very much. Still pretty conventional knowledge representation. And that's not a bad thing. I think it's just there was a good foundation and we can build on it. And Charles, you've been building on that foundation too. So this isn't anything particularly surprising. Okay, now I'm going to throw Michael Miller into the mix here. So
Michael, is that you, by the way?
What?
There's a guy named Michael here. I think that's him.
Oh, no,
Yes.
it's not.
No?
I don't see him.
No, I think
yes.
Michael,
I don't know.
Miller
Who is Michael?
It looks like we have a different guy named Michael.
Different guy named Michael. Michael, what's your last name?
Last name is a Hedor, not Miller.
Okay, not Miller. Okay,
Yep.
Last name of not Miller. Okay, great.
Yep.
All right, yes, that's one bad thing about Michael Miller. His name is just, ridiculous. Anyway, he lives in LA, and I was born in LA, and I was actually planning on seeing him on my trip to Vegas because it's a $21 plane flight. but I canceled it because I had COVID, and so I didn't see him. But anyway, let me do a real broad summary of where I think he's at. In classical AI, at the MIT AI lab in the late 70s, early 80s, there was a whole bunch of grad students, and they all had a thesis. And they usually wrote in Lisp, but their systems were compatible with each other, and they had planners and search mechanisms and, you know, knowledge representation and all this stuff, and they didn't talk to each other. Okay. So I think my gut sort of says that what Michael Miller is doing is wrapping up all those, though, each thesis into a class, and then having conventions that make it easy for the classes to talk to each other. And these classes represent different ways to structure subparts of minds, let's say subparts of minds. Okay. Now, if I'm right on this, and another thing Michael Miller did is invent his own Lisp, and he wrote it in C#. And I'm not really so happy about that, other than the fact that I wrote a Lisp a while ago and then converted it into Common Lisp because it was just getting ridiculous. And that's one of the problems of Lisp, is that there are many variants and they can't talk to each other. And DARPA got really mad, and that's how Common Lisp got created. And then that had its own problems. But in any case, so the reason that I'm happy that he has a Lisp is now he has a val, and he has a val that you can run in a C# program, which ties into what you're doing, Charles, you know, at a base level. But that's not really the important thing, that he has a Lisp or has a val. The more important thing is he's got these patterns, and he did a research of the literature of all kinds of, about, I don't know, maybe 20 different smart AI architectures. SOAR is one of them from CMU, and you've heard of a lot of them. And he has a chart that says, okay, here's these characteristics of an intelligent system, and here's 20, and then down the other side, here's this 20 different systems, and he puts a little dot where each system has a characteristic. So you can see the important characteristics across the top, and the rows are each system and what characteristics he says. And he's trying to make a system that one system that fills in all the dots, right? That can, and what I mean by one system is the same thing that I mean by a language, which is pieces that can easily interoperate with each other. They can call each other, they can get data from each other, they can supply data to each other. Kind of like the UKS is a central knowledge store, right? That is sort of becomes this this centralized place where all the knowledge learned from all these different ways of inferencing and everything can collect, you know, and be there. But I want to be careful. I want to have, maybe we think of the low-level real common inferencing techniques is sort of virtual memory or active memory, or this concept of an active variable. I don't know if you know it, but in certain programming systems, there's a concept of an active variable. It looks like a variable, you know, foo.bar. You just get the value and you can set it to a value. But really, bar is a function that computes something behind the scenes, just returns it. And that's kind of what I'm thinking about these low-level inferencing stuff, right? So there's UKS and a little bit of a virtual UKS that can do this inferencing. And this inferencing may account for 10 or 100 times more knowledge that's in the actual UKS. But from the outside, it kind of appears like it's just, you're just looking up information, you know, and you're just setting information. And that's a good thing. We're doing hiding abstraction. Okay. But then, so Michael's got these components of minds of I imagining capturing all the grad students from the 70s and 80s of the AI labs into a class, right? And now the classes can talk to each other. And then the higher level of where I think he really wants to operate is in architecting minds. We're playing with how to architect a coherent mind. And instead of going down to the Lisp level or some low level to do all these connections, it's like, no, we architect a UKS, which is maybe the memory system. And then we architect hierarchical reasoning, inferencing and stuff, and architect these planning, a planner and a recognizer. And he's got things like an imitator and all this stuff. And then you put together these, let's call them roughly on the order of 20 different subminds. Think of them like a little organ in a certain kind of way that they talk to each other. And that's a mind. And then you play with that and see how it does. Oh, that's not so good at inferencing. Let's swap this part out for that part and adjust the wires here. And then, so you see, we've got this very high level way to implement lots of different minds, making it easy to create different minds. And that's what you do.
We're really
so that's what I've been talking to him about. He's got a couple of books. I don't think they're terribly coherent. You know, I've been helping him a little bit with vocabulary and stuff. He's got a lot of pretty complicated vocabulary, which is a little difficult to wrap your head around. Nonetheless, he's quite concerned with language and all that. And so there's this, if we think of Sally, okay, and the classic, and Charles, you know, Sally's looking out in the world, is collecting, oh, it sees an orange, oh, the orange is both a fruit and a color, maybe we can infer, you know, both two categories from that and all, and that kind of architecture. Okay, now let's consider that as one instance of a bunch of possible architectures, and then the ultimate architecture probably would include Sally. I would think so. I like the idea of Sally. I think it's a good idea. Are there things that we can aggregate on the outside of it at a high level that make sense here and all this? Now, in programming in general, I will observe that we, as, let's call us application developers, for lack of a better word, will often pick some low-level language, doesn't matter, could be Lisp or JavaScript or C# or whatever, and build these structures on top of them that go way high in one direction. They don't have a lot of support from other sides. They don't have higher level support. And what I guess I'm saying is, in architecting these minds, is it's good to have that intermediate stuff, that not like most programs. I think they start off to build a skyscraper, right? And they say, okay, we're going to make a good solid foundation, and that's C#, for example. And then we're going to architect the top 10 stories of the building. But we're not going to architect the intermediate stuff. That's all going to be this random code that's not well organized, not easily swappable, outable, right? So I'm saying this intermediate kind of meso level, pretty high level, but not way at the top, not as smart as Sally, let's say, but lower level down, that we can use the mix and match these components better to make it easier for us to interoperate and play with these architectures. Seems to be me a more robust way to go about is building this complicated beast that we're talking about. Okay, let me stop for a while. I've talked.
Well, let me add something. I think my story is gonna make a lot of stuff generalized and clear about that architecture.
Yeah.
So
okay.
we'll see that.
Go.
And I wanted to add that when we brought NARS in, the non-axiomatic reasoning system from what's her name's Bai Wang, it has maybe 15 different reasoning processes.
Good.
And however, after the first 4 or 5, they turn out to be immensely complicated, that you say, from these facts, can you infer that other fact? And you're saying, well, I sure couldn't do that with a pencil, without a pencil and paper. so I'm not sure. So yes, I'm absolutely convinced that human mind is capable of only a very small number of reasoning processes. And excuse me, without a pencil and paper, you're actually much more limited than you might think. And you say, yes, from these facts, you could infer that, but no human actually does. And so the number of things that you have to be able to write to create a 2-year-old level of processing is actually not going to be very complicated. The hard part is going to be that the input and output processing of the human is just phenomenal. We got eyeballs and earballs and touch fingers and toes and stuff that is just phenomenal, and that's going to be impossible to replicate in a small framework. And the question is, well, what can we do that's efficient, that replicates enough to be able to get the system off the ground?
Charles, do you think my concept of inferring color, is that a reasonable thing for a relatively implementable system to be able to do?
Yes. Let me back up 6 squares. And that is color, I'm not sure is the excellent example, because for color, you have a sensor or collection of sensors that are capable of discerning color. Yes. And so the fact that there is a color may be inherent in the sensors you have and doesn't require any inference at all.
No, but the names of the colors do.
Exactly. The names of the colors and the fact that you have these objects that you see in your visual field that differ only by the values of the sensors in that specific area. And you can give that color a name. But shape would be, I think, a better example.
Okay, yes, shape is an important one.
Because you probably have inherent sensors for corners, but you certainly don't have an inherent sensor for circles, because circles generally don't exist in it's a combination of curvature that you can sense. So I think that if we went to shape as the thing you'd like to be able to infer, I think that's a better example.
And then maybe we could see if we could list, like, maybe colors. I don't have to, I'm not so tied into replicating the human mind exactly it is, but color and shape and size and distance and temperature, and list these. What are we talking about? 20 senses here? Weight, it's not too many. And then from those things, can we build up this richness of a world model, a UK? I mean, I think UKS and world model are synonymous. Is that right?
No, the world model is a subset of the UKS.
Well, okay, fine. Yeah.
Well, the way I use it, the world model is what you think of as in your immediate surroundings. And although there's a lot of stuff in your visual field that you know about, when you think about, well, what do you know about that's behind you?
Yes.
It's only a couple of objects. So your world model has 20 or 30 things in it and 50 that you can see. And so.
But wait, so Madagascar is not in my world model? Is that what you would say?
No, that's a piece of information you have.
Well, okay, but there's some. All right, so maybe we're just talking about what's the definition of world model, but there's some
Exactly.
kind of Michael Miller likes to call them situations, which is maybe a little bit more what you're talking about. What is your current situation? But I do think about Madagascar, even though I've never been there, so it's kind of in my UKS, I suppose.
Yes.
So are you saying that NARS is or is not a good base for this initial set of inferencing techniques?
The inferencing techniques that I know I need is the ability to infer that a category exists based on finding objects that have common characteristics.
Good.
That is an inference that I have to have. And then, of course, the inference of going the other direction, that the dog has 4 legs, is a given. And I think that if we explore that, then we'll find out what we're missing, as opposed to looking at NARS and trying to cogitate on which were the 4 that were the good ones or the one that are good ones. And I'm not even sure that NARS has the capabilities that I've posited, because it's opaque, even though I have the code.
Yeah. I will say that
a lot of Python.
Michael Miller's very into Piaget, and
yes,
he kind of takes his model of Piaget, and I know the word Piaget, but I don't know all the stuff he thought about it, and it maybe some of it is not relevant, or does anybody have a comment on Piaget's thoroughness?
The real key, the thing I really like about Miller and Piaget is that he focuses first on the capabilities of children, and Piaget was a child development guy, and that's what his point of view was. And so when he's talking about now, I'm not sure whether Michael Miller's current systems are related to Piaget, but then Michael draws some very complicated drawings, diagrams of what must be going on in a 2-year-old's mind, and that kind of goes beyond what I'm capable of internalizing. So I have to build something simpler first and see why it breaks before I can go to the next step, something more complicated.
Okay. Yeah. Don't add complexity unnecessarily is the point you're making.
In fact, as you brought it up, where a vision system is ungodly complicated, building a system that would look at black and white bitmaps of shapes and be able to infer shapes out of them might be an exceedingly powerful capability, and a precursor to another a complete approach to computer vision that might actually go somewhere, because you're not showing thousands and thousands of examples. You're showing a small number of examples in a very limited domain.
Yes.
But the key is, so you've got a square. In order to be able to recognize it anywhere in the visual field and in any rotation and in any size, you have to be able to understand what are the characteristics of square, rather than having stored thousands of internal mental examples of square and triangle. And that might be something that would be an exceedingly powerful capability. And I don't think it would be that difficult if we say we were only going to handle cornered objects, because the only thing we recognize is corner. That would be our fundamental attribute.
Well, that's pretty extreme. I do think about vision systems, and I'm annoyed at how complicated they are. But I learned something while I was in Vegas. Google has a chip called Coral. It's an AI chip, and I guess it runs TensorFlow or something. I'm not quite sure. But my dream of what it might be, and I'm not sure that it really is you connect a camera up to the thing, and then you ask it, like, what do you see? And it has the ability, you can train it to recognize a bunch of, like 100 different objects or something like that. But maybe if we trained it to recognize, like you're saying, some simple shapes like squares and corners, and I think circles and cylinders are good, but whatever, right? And then we just ask it symbolically. We compute it symbolically. What are you seeing right now? Well, I'm seeing a cylinder that's this high and a square that's over on the left and all that stuff. And I know its position and its distance. And especially if you have an RGBD camera. You guys know what I mean? RGBD?
What's the D?
D is depth. D is depth.
Okay.
So for every pixel, you get a color, RGB, and then you get how far away it is from the camera.
Boy, that would be nice.
Yes, and there are such cameras. Intel makes a camera called RealSense that approximate this. It's not perfect. But that camera, and then that camera connected to this Coral stuff, and let it do all this fancy neural net stuff for recognizing certain things. And maybe we have it do, for example, recognized faces, because kids are probably good at that, and recognizing, like you say, blocks and cylinders and stuff. And maybe that's pretty good. And then just deal with it symbolically and not worry. And some of us could be in training that system. And because it's this fast AI chip, it can do this stuff pretty quickly and doesn't bog down our main CPU that's doing reasoning with this lower level perceptual stuff. It costs about $100, this chip, $100 to $200. They come on little boards. I don't know, they have a few gigabytes of memory on them. And maybe that's a way to modularize the perceptual tasks so that they don't bog down the higher level stuff.
Mm-hmm. Well, although I have to say, thus far, as long as you forget about the real world, if you talk about images that you might create with simple geometric images,
okay,
they recognize in a flash, or they don't recognize that the amount of the first thing you do, that for some reason eyeballs are really good at recognizing boundaries, and AI is crappy at it. And so it works with a crappy set of boundaries and then spends the rest of its life trying to recover from this crappy underlying data. But if you say, I'm working with black and white images, so I can recognize these boundaries and I know exactly where they are, now all the rest of the flow is really, really fast. And
black, do you mean literally black and white, or are you including gray?
Well, I'd start with black and white and then move to gray. And if I moved to gray, then I could use the MNIST database and prove whether or not I could actually recognize characters.
Yeah, you see, I think if we have the D, it helps a lot in boundaries, because if we're just recognizing,
it solves that problem.
Yeah, you have. I'm thinking of a blanket on a bed. What is the blanket? I'm looking at my bed right now. I have a light green and a dark green blanket, and depth really helps me know the boundaries of the light green, because the light green isn't really light green because it's got all these shadows and everything. So
yeah, but the problem is that your eye doesn't know the depth. It just gets the green and it has to figure out
my
the
eyes
depth.
do know the depth. I got good stereo vision.
Close one eye.
Yeah, so it uses stereo vision and it calculates the depth, but the individual eye doesn't have the depth.
Well, of course, yeah, but that's all.
And if you cover one eye, you can still see those boundaries, and they're really
pretty
good.
much. That's true. You're right about that. Well, anyway,
by the way, I should say I have a certain interesting eye conditions that I won't go into, but it makes me absolutely not a fan of binocular depth perception, because I know that my depth perception is almost as good as anybody else's, and yet I know it's not binocular. So although much is made of binocular depth of position, you do a little arithmetic and you find out that it can't be any good beyond about 5 feet.
Yeah, that's
When
right.
stuff is really close, then it works.
We have there are many cues for depth perception. Stereo vision is only one of them. Yeah.
And certainly if you watch TV, you get the depth cues, but you know it's out of a flat plane.
Well, I had another experience about depth in Vegas. I organized a visit to the local Apple store, and we looked at the new Vision Pro. And if you haven't done this, I would highly recommend it. They give you a half an hour demo. You put on the Vision Pro, and it's pretty good. I've been involved in virtual reality for essentially before it started, and I'm surprised at how good it is. And there's a whole bunch of things about the Vision Pro that are interesting that may come into play as we're thinking about sensors. It's good. It's very brute force. It costs $4,000. They've got 2 displays. One is more than 2K by more than 3K. Each one of them is more than 2K by more than 3K. The frame rate is 90 frames to 100 frames a second. It's a lot of data, but the demo of the Vision Pro is, first of all, it has no light coming from the outside to the inside. It's just cameras and displays. The fundamental demo is you look around the Apple store, as you're setting up and you sit down at a table, you put on the Vision Pro and there's no difference. It looks the same. That's the fundamental demo. They will give you all these, snakes slithering in the grass and birds flying over mountains and all this crap. But the fundamental demo is that. And then that's the real eye opener of the Vision Pro. And we may be able to take advantage of it in Sally and looking around, because there's this.
Well,
yeah. Okay. Well, enough about that.
Let's talk a little about language. And the reason that I'm interested in talking about it is that anything that we have, I mean, if you put words into UKS and you think that the words represent things, you're doomed, because the words are so ambiguous. And Fry, you talked about what you call it, the non-ambiguous language.
Definitive English, yeah.
Yeah. Does it exist?
Sort of. I mean, I don't know. Do ideas exist? I mean, at some point I did have a parser for a version, and then I wanted to change the grammar and stuff. I have a whole lot of, I can talk about its grammar and everything. But it's more, I think of it from our purposes more as a kind of an intermediate data representation. It would be the idea of it being definitive would be you could take a definitive English sentence and know exactly what it meant and map it right into UKS, and that would be it. Now, if you have words with multiple meanings, that starts getting very confusing, unless you are disambiguating by context. And when we have a normal class and a normal programming language, you have methods on that class, and the message can be named foo in one class, and a method can be named foo in another class, but they are different because they're in different contexts. They're in different classes. So I do have the idea of making it easy to make hierarchies in definitive English, and try hard to have one word per class. I'm sorry, one meaning per word. But we might, I know, Charles, you probably have the ability to capture multiple meanings for a given word, and that's okay because that's real in English. But there's a certain stage in which you would like to disambiguate and say, this is red number 2. Red number 1 is maybe the color, and red number 2 is the past tense of reading or something. I don't know, right? But some way to have some canonical token that means one thing, and it might be an English word with a number after it, or just say, when we're in this limited context of definitive English, the word red means a color. It doesn't mean anything else. And and it's more, and I think of it from our purposes, is more of a way to quickly verify that some knowledge is correct, because we humans are good at English. And if we take a narrow subset of English, then that's can be unambiguous. And that's what I'm really going. Definitive means unambiguous. And basically one grammar. And the one grammar is a sentence that starts with an optional subject, and then a verb, which is a command, and then a bunch of arguments to the verb, which you could consider to be adverbs, or if we're building an object, maybe they're actual adjectives.
Can you give me an example?
Real simple grammar.
Can you give me an example?
Yes. Bob, launch the boat. Okay, so in definitive English, I put a comma after Bob. So Bob is the subject. It's the person, the actor that's doing something, launches the verb, and then there's, well, the boat would be a direct object. But I try not to get too concerned about what's a direct object and indirect object and adverb. That sort of, that goes along. I don't want to get too distinguishing there, but that's like a basic sentence. And then I say, when we are parsing text, I've done a lot of text parsing, and you come to a period, or you come to a dot, right? Well, is that the end of a sentence, or is it a period like etc period, or there's lots of, or is it a decimal point, or all this stuff? There's all this ambiguity in text. And especially, what are the boundaries of a sentence? And I just use the Lisp idea to say, essentially put parens around it. I'm using square brackets around like that, but to say, stop with this ambiguity of sentences. Just put square brackets around, so you always know what a sentence is. And then you can have nested sentences easily. And so you get compounded sentences because we're putting square brackets around the sentences, and we know exactly where they are. So we have a very simple grammar. It's so simple that you can easily run the parser in your head from reasoning, not from subconscious. A lot of stuff we do in English is subconscious, right? But you want to be able to run that in your head because you want to verify. You want to run eval in your head. And that's one of the main ideas of eval. If you can run eval in your head, you know what your code means. And so you have a really simple language mapping of syntax to semantics, a real simple grammar, and then it's easy to write code that writes code, because okay, this is the subject and this is the, and you basically have two kinds of commands. These two sentences are, do you have a subject or not? And a lot of time when you're just calling a method, just a normal function of programming, like, you don't really have a subject. Your subject is really computer, computer, do the following thing, you know, is kind of it. So you're
It's usually implied.
The understood you in programming is computer. But I like the idea of agents doing things and directing a command to a particular agent, and that's what the subject becomes. And now you can have the modularity, and you have some of this modularity in your stuff, Charles. I've seen it.
Yeah.
You know what I'm talking about.
Well, here's one of the things that I think of in language that, and we happen to have two people online who are multilingual, and at a kind of fundamental level, that you have to be able to think in a language independent sort of way, and then in the context you get to express that thought in the language of the moment. So
I don't quite agree, Charles.
Yeah.
I learned over time that the best way to speak another language is to also think in that language.
Yeah.
Yeah, if you think in Dutch and speak English, you're going to mess it up.
Huh.
But of course, over time, you learn that certain things coincide. But I often have like knowing the English word for something, but then having to think about what the Dutch word was, even though I'm speaking Dutch.
But clearly, the language you're speaking is a context.
Of course.
And one would assume that if you're asked a question in English, that you will typically answer in English, and if you're asked a question in Dutch, you'll typically answer in Dutch.
Yeah.
And is that ever a mistake you make?
Not often.
It'd be rare.
Well,
so but you don't know when you start to hear a question what language it is, and your mind can instantly determine what language it is and interpret it through this set of contexts.
But that's because all languages have one common core, which we are not consciously aware of, but it is there.
Are you multilingual, Fry?
No. I know a little bit of Spanish and French, you know, not enough. I'm not so big on differences between natural language. I think all natural languages are lousy and unnecessarily complicated and undesigned and all that, and unnecessarily ambiguous, I will say. Yeah. So, and I'm not happy with any popular programming languages. That's another characteristic,
of course,
because they are also unnecessarily complicated and often kind of evolved and not well designed. I see a new language and a new programming language. I look at this and say, well, it's some variant of C that they did this and that, and then I just throw it away because it's garbage. It's not something that's.
I've gotten to like Go.
Well, but it's got multiple syntaxes for a function call, like almost all
no, it doesn't.
Does it have A plus E?
I have seen so many languages come and go in my many years that somebody comes to me and says, we got this great new language, and I say, well, let's wait 10 years and see if it's still there.
No, it's like, if they come to you, it'll be lousy. I'll just tell you, it is.
Oh, okay.
I don't worry about language anymore.
Yeah.
Because I tell the AI what kind of function I want, what goes in, what comes out, what it has to do, and then I tell it to code in this language or that language.
Yeah, yeah. GPT
how do
does
you
it all
tell-
for you.
And how do you tell it? You use a language called prompt
English,
engineering.
yes. But
No,
I'm pretty
prompt
good at it.
engineering. It's not English. Or GPT English or something. I
Right.
name these languages. And they're not English. They're a different language, and you have to learn that language.
Yeah.
Well, did
Okay,
you
we've
know-
got to.
Prompt
We're gonna
GPT
wrap
is
up here
not
pretty.
a designed
pretty-
language.
Yeah.
No. Did you know that you can actually work around restrictions that they put in the system prompts by using ASCII art? The
By using-
LLM recognizes
By
it.
using what?
What?
Art.
What's that?
You don't know ASCII art?
No.
Oh, ASCII art. Oh, yes, I know ASCII art, but with so what? That's another
Oh.
very ambiguous language. So what? You know.
Yeah. but
Okay.
the point is
Guys.
that-
Yeah. Let's forget
Okay.
it.
We need to wrap up because I'm running out of energy. And William asks, can he work on the Brain Simulator 3? Of course. I think you have to get, well, you can download the code and make sure it works. I don't know if you've done that. And after you've done that and get an idea that you actually can make things run, you may need to be granted access to the
GitHub. Yeah.
To the GitHub in order to be able to actually create branches and do stuff. And then the next thing is decide what's the stuff you want to do. So, William, you can write an email or whatever you like to get in contact or through the GitHub. I think you can message through the GitHub. Is that correct? Yes. Certainly to request access. And then what we'll do is I'll put together a special meeting next week for Andre, you to introduce your stuff.
Mhm.
And what I want you to do is to send me the paragraph that describes what you're going to talk about specifically, that I can put in an email that says, come to this meeting, this is what it's going to be.
Okay. I will do that, but one condition, you can't plan it on Tuesday.
No, I was going to assume Thursday,
Yeah, sure.
but Thursdays and Fridays are my favorite days.
No, but next Tuesday I have Repair Cafe, so then I won't be here.
Okay, and let me okay, so William, thanks. I look forward to hearing from you. Andre, thanks. I look forward to hearing from you. Zaid, we haven't heard from you, but we're glad to hear from you. Mind Manager, glad to meet you. Fry, good to see you again. And we'll put together a general meeting a month from now and an Andre meeting a week from now.
Andre meeting,
But
wow.
but also at the Andre meeting, we should be able to have, I should by then have recovered enough to put together some ideas on how to move stuff forward. And I realize as we're talking about it, the language, the decision making, and the sophisticated search stuff, all of that sort of exists in the previous version and needs to be just needs to be translated. And so when I was talking about the pattern recognition, the shape recognition, I seem to remember having written that just a year ago. Yes, we can, and it's essentially what we need to do is to translate stuff into the current brain simulator release and make it robust enough that it will survive more than the single test case that it was previously able to pass. And I'm getting, this has been a great meeting for me because I'm getting a lot more excited about working on the project again, and I'm no longer in the land of ice and penguins, and
Monochrome.
Yeah. Oddly enough,
that's where you got the black and white from.
Yeah, exactly. Boy, I could recognize those pictures. Of course, there's this bright blue in some of the ice too. That's wonderful. And although they say there are no polar bears down there, we took, and we get out in the zodiacs and we go around the icebergs, and then we come across another zodiac, and there are 2 polar bears serving hot chocolate from the zodiac. So I've seen at least 2 polar bears in Antarctica, even though that's alleged not to exist. But I saw thousands of penguins, and boy, do they smell the high heaven. So I want to thank you all for appearing, and I wish you well, and I'm going to leave you for your own devices. Thanks a lot.
Get healthy.
Bye-bye.
Next time.